Welcome to planet Earth, that big blue marble that floats around through space. Third planet from the sun, or as I call it, home. Now this little planet is very unique in many ways. It comes fully self-contained. Everything we need to survive is right here on this planet. It's up to us humans to use these resources wisely. Sometimes resources are forgotten. Such is the case with fertilizers, more specifically minerals and trace elements. And this is what we will be talking about today. In our modern fast-paced society, things keep moving faster and faster. We're willing to sacrifice natural quality for convenience. We go down to the hardware store or the nursery, and there's rows and rows and shelves of products of all descriptions, all sizes, bags, bottles, boxes, you name it. So what do? You grab a whole bunch of it. Sometimes you pick it up by color, sometimes by directions. You run home, you play scientist. Sometimes things work, and sometimes things don't. When it don't, you run back to the hardware store. You get something that says all-purpose, straight across the bag. For everything you grow, you can't miss. It's got the nitrogen, phosphorus, and potassium. NPK. But let's take a look at this NPK. Let's start with the nitrogen. How does this happen naturally? Lightning. Lightning strikes the earth about once every second. There's a strike somewhere around the world. And as the lightning passes through the atmosphere, it slices the hydrogen atoms into nitrogen. And that's how the earth replenishes the nitrogen naturally. Now let's take a look at the second number on the bag, phosphorus. Every day at noontime, and you can just about set your watch by it, the Sahara Desert kicks up a dust storm. This dust storm, which has actually been photographed by NASA, sends a plume of phosphorus not only across but around the world, dusting everything around. Now the third number on the bag, potash. Potash is a result of wood burning. Fires are burning continuously around the world at any one time. Here's a satellite image of the fires in Greece this past year. Notice the plume of smoke sending potash. Also Southern California is just another example of fires burning around the world. So there we have our NPK. Green foliage, strong roots, healthy growth. What more could we ask for? If you take a look at the periodic table, you'll see that there's over 110 different minerals and trace elements. However, we only focus on nitrogen, phosphorus, and potassium. What about things like boron, silicon, calcium, magnesium, carbon, manganese, copper, zinc, and iron? These are all required minerals and elements too. If some of these look familiar, well, they should. They're on the back of your multiple vitamin and mineral tablets. You see, the human body requires up to 72 different minerals and trace elements. And like the human body, tomatoes, other plants all need minerals and trace elements. A tomato alone requires 56 separate minerals and trace elements. Trace elements aid in cell building. Cell structures are very complicated. There's a lot going on in a cell structure. Here are cells from a healthy plant. Notice how green they are, how strong the cell walls are, how packed tight they are. Compare that to this one. This is a sick plant, a weak plant. The cell walls are weak. It's sickly. Crops grown in soil that has been depleted of minerals and trace elements will experience plants that are weak, stunted growth, low yield, and even more susceptible to pests and disease. This is not just a problem for the backyard gardener. This is a problem on a worldwide scale. Large farms, ranches, fields. Here's a vineyard in France, dying due to a lack of minerals and trace elements. So what's going on? How does this happen? I put the NPK all-purpose like the bag said. Well, let's take a look at what's going on. Every time we harvest a crop, whether it's in our backyard or in a field, we remove minerals and trace elements. We put back NPK. That's 3 out of 110 minerals and trace elements. In 1948, a bowl of spinach had 72% more iron than a bowl of spinach today. Today you would have to eat 72 bowls of spinach to get the same amount of iron as you would have a bowl of spinach in 1948. So you think you're safe if you grow your own fruits and vegetables in your backyard? Maybe not. If your garden's over 3 years old and you have not added any minerals or trace elements along with your NPK, then your soil might be depleted of minerals and trace elements. Now let's take a look where minerals and trace elements come from. Now, as I said early on, planet Earth is totally self-sufficient. To understand more about these minerals and elements, we have to look deep inside the Earth. In the center of the Earth, we find hot magma. This magma is comprised of minerals and trace elements. Now, we all know what happens when magma moves up through the Earth's crust and breaks through. Volcanoes happen. Interesting thing about volcanoes and magma, no matter where in the world magma pops out of a volcano, chemically it is identical, all coming from the same center core of the Earth, no matter where in the world it pops out. Now let's take a look at a side cut of a volcano. On the left side, you'll see extrusive igneous rock. Now once the magma from deep inside the Earth comes up and erupts out the top as a volcano, it spews out lava. Inside the Earth, it's magma. Once it breaks the surface, it's lava. On the right-hand side, you'll see intrusive igneous rock. Now intrusive simply means that this magma did not break the surface, but merely stayed and spread underneath the surface. Now there are 3 basic rock classifications: igneous rocks, sedimentary rocks, and metamorphic rocks. First, let's look at igneous rocks. Igneous rocks get their start deep inside the Earth as magma. This magma then rises up through the volcano and is either extruded or intruded. Now as the volcano starts to go dormant, cooling process begins. As this cooling process takes place, the minerals and trace elements inside the magma start forming crystals. Now the slower the magma cools, the larger the crystals, such is the case with granite. Granite is an igneous rock that cools very, very slow deep inside the Earth. Basalt cools a little bit faster than granite, therefore the crystals are somewhat smaller. Next we have rhyolite. Rhyolite is the fastest cooling igneous rock. Therefore the crystals in rhyolite are much smaller than basalt or granite. Even though they cool at different temperatures, they look different, they still have the same chemical composition. Now when I say one cooled faster than the other, we're talking millions or hundreds of millions of years. The second rock classification is sedimentary rock. Sedimentary rock is just that, sediments that have floated down one way or another, either from the sky or from water, and have been compressed into solid stone. And the third classification, the metamorphic rock. A metamorphic rock is a rock that can change from one type of rock to something else. Under high pressure, high heat, it can change even into a diamond. Now, of the three rock classifications, we're going to concentrate on igneous rocks. Only igneous rocks contain all the minerals and elements from the center of the earth. Not all rocks have all the minerals and trace elements needed. Let's take a closer look at rhyolite. Rhyolite is a very common rock in the western United States. Yellowstone National Park not only sits on top of, but inside of a giant caldera. A caldera is the inside of a volcano that has cooled and settled down. The Yellowstone caldera is 34 miles wide and 45 miles long. In this drawing of a side cut of Yellowstone caldera, you can see the rhyolite tuff or cap. Also extending from each side is the rhyolite blankets, and that covers a great distance, sometimes up to hundreds of miles. This rhyolite blanket is intrusive igneous rocks. Perfect example. We've seen where the minerals and trace elements come from. Now let's see how they're distributed. Glaciers played a major role in the distribution of minerals and trace elements. By merely grinding away at the rocks, they've turned it into a very fine powder that was then carried downstream. Yosemite National Park, perfect example of a glacier that has come through and carved away at some solid granite. All the minerals and trace elements that were once solid granite were then allowed to wash downstream where it would flood the fields, replenishing the minerals and trace elements. Getting our minerals and trace elements from the earth is nothing new. We've been doing it for centuries. Native Americans unknowingly got their minerals and trace elements simply by utilizing the stone. Every time they grind their flour, they grind a little bit of the rock away, which carried the minerals and trace elements. All around the world, people got their minerals and trace elements directly from the stone, one way or another. However, the natural process of mineral distribution is no longer allowed to happen. We construct levees, build canals, we change the course of rivers. We do not allow the waters to flow across our farmlands any longer. There are those that say this is a better way. We can feed more people. We're feeding more people. Less nutritious food is what we're doing. So what do you do? Well, you have several choices. One, you can sit around and wait for the next ice age to come by. Maybe that will redistribute some minerals and trace elements your direction. Two, you can pack a lunch, get a sledgehammer, go find some igneous rocks, and make your own rock dust. Or three, find a local quarry that specializes in igneous rocks. Now what you will be looking for is igneous rocks that have been ground into a real fine powder. Now you take this rock dust, you spread it around your garden in a thin layer. If you haven't done it in a while, I'd recommend about an 1/8 inch layer. Now what could be easier than that? As far as the benefits, rock dust is 100% natural, will not burn your plants, increased growth rate, increased yield, optimally nutritious produce, great tasting produce, dramatically decreases the number of insects, plants that are more resistant to disease. One application lasts up to 3 years. Plus, it speeds up the process of composting, and so much more. And what about our farm animals? Don't they deserve healthy, nutritious food as well? After all, they're feeding us. With all of us working together, we can put the nutrients back in our food supply. After all, you are here. Thank you.